Okay, so just quickly, in this video, we are going to go through your assignment, which is worth 20% of the whole mark for your bivariate data topic. The 80% is going to come from the verification test. So if you go ahead and copy your mate next to you and get their answers, well, you know what? You're only getting 20%. You're not going to know what you're doing. So that's why we have a verification test, which in your case is going to be on Thursday. All right. So of course we've got first of all here we've got, what type of data is this? Is this categorical or numerical? It's categorical data. Okay, so but the categorical data can then be, we can get a value and we can tally those up. Now I'm going to ask this. We've got 8 public transport full-time. How many part-time did you have, Stefan?
For full-time, I had for part-time I had 3.
So he had 3 here, is that correct?
Yeah.
Okay, good. And what about for car, what did you have?
For car, for full-time, I had 5.
For 5. Do we all agree with that?
Yes.
Okay, so of course 8 plus 5 is 13. 8 plus 5 is 13, isn't it? And 3 plus 6 is 9. Do you agree with that?
Yep.
Yeah.
And then we can then fill this out, 11, and that's 11. And of course 13 plus 9 is 22, 11 plus 11 is 22. All right. Now, the thing is that we've got here public transport is 62% full-time. So, and this is, by the way, this is what we call 2 significant figures, 1, 2. If I was asked for 3 significant figures, it might be 62.7. This is 3 significant figures. Does that make sense? Okay. So, then, therefore, what's part-time?
33% for public transport.
For public transport?
Oh, sorry, for full-time car, it would be 48 or 38.
Full-time car is?
38.
38, thank you. Now, what some people did is they worked this out as 38. Is that correct? No, it's not. So
That's 33.
that's right. Now, that's 33 because 3 out of 9, 3 over 9 is 33. But the thing is, it's 33.33, but because it's the 2 significant figures, we need to have 33%, don't we? Okay, so that's good, 33% and 38%. Now, of course, my percentage has to add to 100, so I don't even have to work that out. But I can work that out as 67%. Now, of course, where did we get that 67% from? Well, we worked out 67% because we did 6 divided by 9 times 100. Okay, we had 6 people who drove a car part-time out of 9. So that's where we got the 67%. But actual fact, if we ask for 3 significant figures, what would we do? Let's have a look at our calculator. And I do 6 divided by 9. And I go to that. What happens if I was asked for 3 significant figures? What would you have to do?
66.7.
66 point, and would round that off to up 66.7%. Does that make sense? All right, that would be 3 significant figures. All right, so I just wanted to show you that. Now, we go over here. How many people surveyed use public transport in the survey? This is the easy peasy Japanesey sort of stuff. Cam, what did you get for that, mate?
Which question?
What did you get for that one?
About
B?
22.
Do we agree with 20?
11 or 33%.
Okay, so how many people? Don't go wasting your time by saying 11 or 33% because the answer is 11. It's worth 1 mark. So it is 33% is if you just wrote 33%, you get 0 because you wrote the 1 mark. You're doing extra work that you don't need to do. Okay, how many people? Okay, so importantly, I like your attention to detail, but sometimes you just need to remember that attention to detail can waste time in an assessment. Okay. Now, how many people were surveyed?
22.
22, yeah? We okay with that?
Yeah.
Easy marks, easy marks. Use your percentage two-way frequency table to construct a segmented bar chart for the data. Now, can someone please tell me, or I might sort of pick on Romy. All right, Romy, I'm going to... Okay, now what you've got to do is I want you to write for me what goes on the axis and things. What did you do on the axis? Now, she's going to learn how hard it is to actually draw on this thing.
Wow, yeah.
It's not that easy. Okay, so we've got full time, and what's the other thing that we were comparing?
Part-time.
Part-time, beautiful. Okay, would you like to have a go? Would you like to have a go at the what we call the y-axis as well?
What, draw the actual...
Yeah, no. Just what do we label that? Percentage. Percentage. Yeah, because this could be bananas. It could be time. It could be minutes. It could be kilometres. So you of course probably wouldn't have to write it like that. You'd probably write it like that. But yeah, okay. Thanks, Romy. Well done.
I'm having fun.
Having fun?
Yep.
All right. Now, what a lot of you did is this, and I'm going to do it, and then I'm going to rub it out. Because it was very disappointing, but the problem is that I wasn't here that class. So, but what we did is this: we were actually like doing and comparing things like this. No. Because and look, I'm telling you now, in your assessment, you're going to get something like this. It's going to be what we call a segmented what? Bar chart. Okay, use segmented bar chart. Make sure you label your axes. We've done that axis. And give a key for your data. Give a key for your data. A lot of people don't do that, and you will lose marks. So what you want to do is we're doing a segmented bar chart, and you need to label your axes. There's actually 3 things. That's why this would probably be worth 3 or 4 marks. Okay. Now, full time. How many? What did we have? We're comparing. What was it? Males and females, or what was it? Full
transport car.
PT and car. Yeah. Okay. So how many people? For full timers? What was the full timers for PT?
62%.
62%. So roughly, I'm just going to do this. Okay, I'm going to do this, and I'm going to go about there. Okay, and that was PT 62%, and I'm going to basically say that's that there. Okay, now that means that PT public transport is equal to, or is this thing here. Okay, that's what we're talking about, our key. All right. Then that means that there's 38%, and of course it has to add to 100, doesn't it? These segmented bar charts have to add up to 100 when we're comparing these variables. So what we do here, we go car, and we can even write the percentage. Okay. Now that's going to be car. Okay. Now what we do is, what was the percentage? Wasn't it? What was the percentage for PT for part-time?
33.
33. Let's do car then. What was the percentage for car? 67, wasn't it?
Yeah.
So 65, 70, 67. Let's just sort of do something around there just for argument's sake. Make sense? Okay, so we've got car, 67%. And of course we keep doing our thing. That's our key. This is our key. Now, how would we give you? Now we'll give you a mark for a key. Okay? We'll give you a mark for both labels being correct. Okay, so a mark, but that's if this is correct and this is correct. And then we'll probably give you 2 marks for identifying this and making a segmented bar chart. But I haven't finished yet, have I? Because that needs to go there, and that is PT, and then according to my key, that's going to be 33%. Are we okay with that?
Yep.
All right, good. So now this is actually worth 3 marks. So what they've done is they're probably going to say that the key might be worth a mark, the data might be worth a mark, and then maybe labelling the axis correctly. So if you label this one correctly but not this one, then you lose a mark. You can't just get the mark for doing that because anyone can label an axis. Make sense? Okay, so we're going to move on. From your results above, comment on whether or not a relationship between student and type of transport exists. Now, the thing is that this is the most important thing, all right? Now, I'm going to pause this for a sec. Now, as I just said to you, I'm going to say it again. Percentage is the reason why we can determine whether there's a relationship. In this case, what can you say, Mr. Woodward, about the relationship between public transport and, full-time and part-time? What would you say?
I'd say there seems to be a relationship in which twice as much full-time employers catch public transport, whilst many more part-time use cars.
Yeah, so there's definitely a relationship between PT. Would you agree with that? Yeah? Yeah, absolutely. I would agree with that too. Now, I'm not going to write that down, but I'm going to summarise it quickly because this is 2 marks. If you say yes, do you think you're going to get 2 marks for yes? You might get 1. I might even give you a half for being so lazy, okay? Because if something says, make sure you refer to your data, yes, it appears as though, yes, 68% of
62.
Okay, 67%. 67% of part-timers use a car compared to 33% using PT. Alternatively, referring to your data, 62% of full-timers use public transport. Okay, now I'm not going to continue on with that because otherwise we'll run out of time. I'm going to keep going. All right, now, first of all, we've got question 2, and question 2 is all of this. Now, of course, we've got to put that in our calculator first, okay? And you know how to do that, don't you? I've shown you how to do that. Now, it says here, given students don't choose where they live, read the following statements to identify which is correct. The time taken travelling to TAFE depends... What's that? The top one.
I think it's A, like those 2 statements.
Oh, yeah. The time taken travelling to TAFE depends on the distance, or the distance the student lives away depends on the time. Yes, of course, it is the top one. So what does that mean? That this time, now I did say that time mostly is the explanatory variable. What is time in this case? It's the response variable. So time is the response variable and distance is the explanatory variable. Okay? Now this is one of those examples, but now it says, hence identify the response variable. So the response variable is time. Construct a scatter plot of the time against the distance travelled. Yada, 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 yada. Now, I'm not going to construct a scatter plot because that's going to take time and you guys know that. But what, of course, you need to do is you need to look at, when doing a scatter plot, we've got a minimum time of 3, a minimum distance of 3, and a maximum of 50. Okay, so this is what I want you to think about. So we've got a minimum distance of 3 and a maximum of 50. Now then I look over here and I say the time, I've got a minimum time of 5, and what's the maximum time? Is it 90? Okay, got a maximum time of 90 and the minimum time is equal to 5, wasn't it? Okay, I believe it was. All right, so first of all, what's our response variable? Time. Time, and time in what? Time in light years? Minutes. Okay. What about over here? What do we label this as? Distance? Kilometres, yes? Now, I'm not going to do the scatter plot because that's just going to waste my time. And you should have done it. But if I have a look, you really need to order those things, and you can order them in your calculator. But I'm going to say that, like, I've got something like 5 and 3. 5 and 3. 5 minutes, 3. What's our maximum time? 90. So if my maximum time's 90, how many squares do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 8. You know what? I'm going to go up in 5s. There you go. There's 90. Okay. So these I'm going to go up in 5s. And my maximum distance is 50. Yeah, it was. 5, 10, 15, 20, 25. You know what? I'm going to go up in 2s. So I'm going to have this as 50. That means that's 10, 20, 30, 40, 50. And that's the main thing that you need to do. And that would have taken you a while. Did it take you a while?
Yeah.
To do that scatter plot? Okay, so let's just say you put some points in, 10, 18, 10, 18. Where does the 10 go? Ooh, is it time or distance? Distance, distance, distance. So 10, 18 is going to be 10, 18, 5, 10. All right, there you go. So either way, you keep plotting points. Okay, you keep plotting points, don't you? Shh. Now, use the scatter plot to describe the relationship between the variables in strength, direction and form and outliers. Now, first of all, okay, we discussed this already. When we're talking about strength, we're talking about weak. Obviously, there's a no relationship, and you'll never get a question with no relationship because what's the point in doing it? There's weak. What's the next one? Moderate. And strong. Strong. And no relationship. You won't even get one like that. So let's just say weak, moderate, strong. Direction. Negative or positive. Positive or negative? You can do this in your bound reference. So we've got a strong, and it's either linear or non-linear. Now, after you sketched your scatter plot and did a line of best fit, what did you classify, Spinksy? What did you classify it as?
It was a weak, moderate, linear relationship.
A weak, moderate. Okay, now I'm going to say that, what did you find for the R value?
0.7402.
Okay. 0.74, I'm going to say that is pretty close to a strong, because strong is from 0.75. Isn't strong from 0.75 to 1? Is that right?
Moderate 75.
Yeah, what?
Could be either of those.
Yeah, no, it's not weak.
No, moderate.
Moderate, yeah, it'd be moderate, but can't it also be strong? Like if it's that close. Now, I'm going to accept, I would have accepted two things. I wouldn't have accepted weak, because the R value, which the least regressions line you find in your CAS calculator, now I'm not going to put those points in, or maybe I have done so before, but I'm going to have to go. Now, I don't think I've saved it. I think have I? No, I can't. I haven't saved it. I'm not going to put it in now, because we're off in 4 minutes. But what we're going to say is I would have accepted, because of the Pearson's coefficient R, I think it was 0.749 or something.
7.02.
Okay. I would have accepted, clearly by what you've got in your bound reference, it is a moderate positive linear relationship. Did there appear to be any outliers?
Yes, there was one. All the way up there.
With
90 and
an outlier at 50-90, was it, or 90-50?
no, 1590.
At 15-90, yeah? Now, I would have also accepted strong positive linear relationship, because that 0.74 something was very close because of the notes, and we've been through all of that. Now, it says determine the Pearson's correlation coefficient R value. Now, the thing is that I've shown you how to do it. I'm going to show you where it is, and but I'm not going to show you for this question. Okay? When I go to my CAS calculator, and I'm just going to make one up. Okay? So I'm going to do this right now. Don't say that, because that means someone farted.
Oh no, it's my white out.
Okay. All right. So if I do a 2, 4, 6, 8, 10, and then over here we're going to go up. We actually, you know what? Every time we go up, we're going to go down. So let's start at 10, and we're going to go to 8.2, and then we're going to go to 5.4, and then we're going to go to 3.7, and then we're going to go to 1/5 of 10 is 2.3. Okay, now I've just made this one up just for argument's sake. Can no one's going, obviously, until I get just this part finished, okay? Good? Okay. So, what do I do to, first of all, get the things such as this least regressions or Pearson's coefficient? Can someone put their hand up and tell me what do I do? Can?
You have to get the scatter plot up first.
Okay. Now, we don't necessarily have to get...
Oh, wait for the regression. Don't use
We can go to menu, statistics, stat calculations, and
It's 4.
now the problem is though, right, let's call this A and B, yeah? Okay, because otherwise it might get a little bit confused. Now let's try this, so let's try it again. So we're going to go to menu, statistics, stat calculations, linear regression, yeah? We're happy with that?
Yeah, 4.
Okay, now the X list is like the thing that we're starting with. A, and then we've got B, and then we're just going to put it into the next column. All right, now, what do you notice about that thing? As we were increasing A, what was happening to B? It was what?
Decrease.
So should it be a positive or a negative line? So what's our R value going to be? Negative. Let's have a look. Now, I just made that one up. Now, let's have a look at the R value. What is the R value? Okay, that, now, to 4 significant figures, what is that?
Negative 0.993. 993.
993. Is the 0 a significant figure?
Yeah.
Yes, it is. Okay? Does that make sense? All right, so what we have to do here, just quickly before you go, okay, is that's how you find your Pearson's coefficient. Now, what did you get? Someone tell me, because we're not... 0.74. That's 3 significant figures. 0.740, isn't it? Now, what's the interpretation? What does this mean? It's a moderate, positive, and it says use the least squares regression method to find the equation. Now, remember that I've just made my thing here. Sit. I don't care. Sit. Okay? I'm sorry, but I just want you to just see this last thing, okay? And then I promise you. So then we go to home, and then we go here, and then that's when we have to create a scatter plot. Now, of course, A was it A there? Okay. And B was there, wasn't it? Okay, and what do you notice? It's a line that I made up, but it's actually a pretty good negative line. Now, how do we find that regression analysis though? We go to menu, analyze, regression, show linear A plus BX. This is what we call the least squares regression line. Okay? Now, that means that you would then put that value in, and if you grab that little tool here, you can move it around. Whee! Right? That's what you guys have got to do. So I'm going to stop there. You have to put that formula that you get from that in there.
But it says not y, so you just change it to t this time.
Yes, that's right. We don't want you to do y and x because we're asking for t and d. Okay? Interpret the meaning of the gradient of the regression line. For every time, now in this case, every time I go across 1, how many times am I going up or down? Every time I go across 1, I'm going down 0.9. Yeah? Okay. Now I'm going to stop there. I do thank you for that. And I will finish off the rest of it. But can you please make sure you finish it off for homework tonight? Okay? Thank you.